Namaste students, this is Seema Bhardwaj on behalf of Maths Department from Samanvatika. Today we will be starting our chapter 8, that is Binomial Theorem. In your earlier classes you have learnt that on the basis of number of terms, polynomials or expressions are categorized, classified as monomial, binomial or trinomial. If expression has one term, it is called monomial. If expression has two terms, it is called binomial, and if expression has three terms, trinomial, and so on. In this chapter, we will be dealing with binomial expressions. So, any expression with two terms is called binomial expression. Earlier in junior classes, we have learned the squares and cubes of these binomials. We have learned the formulas. Say if we write a plus b whole square, we know that it is a square plus 2ab plus b square. Same way we can write for minus also. If we write cube, a plus b whole cube, a cube 3a square b plus 3ab square and b cube. But if someone asks you to write the identity for a plus b power 5 or a plus b power 7, in this case it will be somewhat difficult for you to write the formula, to write the identity. To overcome all these problems, we will be studying binomial theorem. Before we come to binomial theorem, let us observe the identities again. If we write anything power to 0, a plus b power 0, we know that it is equal to 1. If we write a plus b power 1, means no need of opening, a plus b only. A plus b square, as I written earlier also, a square plus 2ab plus b square, and for a plus b whole cube, we have written this identity. Now what do we observe? First point, number of terms. How many terms are there? 1 term, 2 terms, 3 terms, 4 terms. Number of terms of each expression is 1 more than the power. If power is 0, number of terms is 1. Power is 1, number of terms is 2. Power is 2, number of terms is 3. Power 3, number of terms 4. So number of terms is equal to 1 more than power. Power plus 1. Second thing, we can observe that first quantity, it's a square, then first quantity keep on decreasing and second quantity keep on increasing by 1. Here a cube, b is not here, b is not here means b is 0. Now a became square means 1 less and b has increased. A, a3, a2, a0. Then b is having 0 power, 1 power, 2 power, 3 power. So first quantity is decreasing by power 1 and second quantity is increasing by 1. A is decreasing, A's power is decreasing and B's power is increasing by 1. Third thing, we can observe that the total power is equal to the power of the question. If it is square, if we are opening a plus b whole square, power is 2. Here also 2, 1 plus 1, 2, 2, 3, 3, 2 plus 1, 3, 1 plus 2, 3. So ultimately, total of powers of power of A and B is equal to power of a plus b. Now if we arrange these coefficients, if power is 0, coefficient is 1. With power 1, A is having coefficient 1 and B is having coefficient 1, numerical coefficient. With power 2, coefficient of A is 1, 2, 1. With power 3, this kind of arrangement is called Pascal's triangle. This is known as Pascal's triangle. What do we observe? This is 1. Here, this is 1 and 1. If you add this 1 and 1, is giving us 2. Every time first term is 1 and last term is 1. And in between terms, how we are getting? By adding the terms. Here it is 3, 1 plus 2. This is 2 plus 1. First and last is 1. Now if using this Pascal's triangle, we try to write a plus b power 4. How will we write? This is for index 4. First entry has to be 1. Then 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. And last term 1. Same way if we write for, that means how will we be writing? 1. That means A4. And those observations are written that first quantity will come with same power, A4. Now this will keep on decreasing, A3, and second quantity will start increasing, B, and coefficient has to be 4. Then coefficient has to be 6. A will decrease, B will increase. Then after 6, again 4. 4, A will decrease and B will increase, and in the end 1 means A has totally vanished and we are having B. Same way we can write for 5 also. How to write? For 5 part, first 1, then 4 plus 1, 5, 4 and 6, 10, 6 and 4, 10, 4 and 1, 5, and last one 5. Then again see how to write. First quantity, same part, A5, then 5, this will keep on decreasing, A4, B, then after 5 it is 10, 10, A3, B square, and see sum of parts, 4 plus 1 is equal to 5, 3 plus 2 equals to 5. Then after 10 again 10 comes, 10, A is decreasing, B is increasing, then 5, A, B4, and in the last it is 1, coefficient 1, so it will be B5. So we have written the formulas of A plus B power 4 and A plus B power 5 with the help of Pascal's triangle. But again a problem comes if we have to write for say power 12. For power 12. So what we'll be doing? We'll be writing all the coefficients. We have to complete the triangle, Pascal's triangle. Again this process will be a lengthy process. In such a situation we need a formula which gives us easy solution, and process should not be that lengthy. For that we'll be learning binomial theorem. In your chapter of permutation and combination, you have learnt that when we write NCR combinations, it means n factorial upon r factorial n minus r factorial. And you have also learnt that 1c0 is equal to 1, and if we write ncn means 0, combination with 0 or 1 with 1, it is also 1. Now let us try to write this Pascal's triangle in form of combinations. Here we have written 1. So for 0 power, can we write it as 0 power 0c0? For 1, we are having 1 and 1. So 1c0 and 1c1. For 2, 2c0, this is 2c1. 2c1 means 2 factorial, 1 factorial, and 2 minus 1, 1 factorial. So 2, and here we can write 2c2. Write it. Let's write it properly. So we can write Pascal's triangle with the help of combination for power 0. It can be written as 0c0. For power 1, 1c0 and 1c1. For 2, 2c0, 2c1 and 2c2, and combination with 2 is 1. I am converting this Pascal's triangle into this form. Here with 3, it will be 3c0. 3c0 means 1 only. Then 3 combination with 2, 3c2 will give us 3 only. 3c1 will give us 3. Then 3c2, again it will give 3. Then 3c3 will give us 1. Again for 4 we can write, 5 we can write. So if suppose now I want to write for part 7. So can we write it straight away? No need of completing this triangle. Straight away after 3 if I want to write for 7. 7 C0, 7C1, then 7C2, 7C3, 7C4, 7C5, 7C6 and 7C7. Count number of terms 1, 2, 3, 4, 5, 6, 7, 8. I have told you that number of terms should be 1 more than power. Now if we try to write down the formula, how can we write it? Earlier it was difficult for us to write the formula, but now if we have to write, suppose we want to write a plus b power 7. We will be using this and the observations which I told you. First of all, 7C0. And first entry I have told, first quantity will be with 7 power. A7, then 7C1, A will decrease by 1 and B will increase by 1. Then 7C2, A5, B square. 7C3, A4, B3. 7C4, A3, B4. 7C5, A square, B5. Sum has to be total equals to 7. Then 7C6, A, B6 and 7C7, B7. Now if you open it, you will get your answer. 7C0, it will be 1. So 1 into A7 means A7 only. So we can write straight away A power 7. Then 7C1 will be getting 7 only. 7 A6 B. Then 7 combination with 2. 7 factorial upon 2 factorial. 7 minus 2, 5 factorial. So we will be having 7 into 6, 2 into 1. This 5 factorial you get cancelled. We will be having 21 A5 B2. Same way if you open 7C3. 7 factorial, 3 factorial, 4 factorial. 7 into 6 into 5, 3 into 2, 35. A4, B3. 7C3 and 7C4 will give the same answer. 35, A3, B4. 7C2 and 7C5 will give same answer. 21. A square, B5. Then 7C6 will give same answer as 7C1, 7. A6 and 7 combination with 7 will give us 1, 6, B power 7. So I could easily write the formula of A plus B power 7 with the help of this combination when used in Pascal's triangle. Now we can very easily write our binomial theorem. According to binomial theorem, if we write a formula of, if we write an identity of A plus B power n, it will be nc0 an nc1, A will keep decreasing, P has started, then nc2 an minus 2 B square and so on, and in the last we will be writing NCN, A will not be there, Bn. So this expression is known as binomial theorem, and we can, by putting the value of A, they say write A as 2x and B as 3y. Very easily we can, and power 3, or power n power we can have 5, 7. We can very easily open these expressions.